For this section, we are going to explore the application of HCF and LCM. So we're going to apply HCF and LCM into the problem solving. So sometimes in this context, it is also known as the real world context. So okay, RWC is like real world context. So this is your first topic in secondary. So there will be all the topics, right? As much as possible, there will be this real world context. So in another words, it's something like problem solving. So in this section, we are applying our technique of HCF onto this kind of question. So the important thing will be to tell whether a question is HCF or LCM. So I'm going to show you 4 examples. Hopefully after the 4 examples, you got an idea how do you tell whether a question is a HCF question or LCM question. So if you have looked at example 6, okay, a distributor has 48 apples, 78 2 oranges, and 96 pears in the storeroom. Each type of fruits is going to be distributed equally among a certain number of baskets. So we are going to distribute these 3 fruits in a fruit basket. So we were, with this amount of fruits, we are wondering how many fruit baskets that can be prepared. So in this sense, what are we trying to do? We are trying to divide out the 48 apples. We are trying to divide out the 72 oranges and the 96 pears. So when we want to divide numbers, we are exploring the factors. So like 48 can be divided by 2, 72 can be divided by 2, 96 also can be divided by 2. So we are going to find a common number where the apples, oranges, and pears can be divided by. So in a way, that will be the HCF. So this question is actually a HCF question. So if you already decide that it's a HCF question, so what you can do is you do your prime factorization. So you do your ladder. So recall the steps for HCF. So your job is to do the prime factorization. Okay, so I'm not going to show the prime factorization. You show in your own way. So most of you will be showing through the ladder method. So I'm just showing the final answer for the prime factorization. So after the prime factorization, your aim is to get a HCF. So before you try to get the HCF, make sure they are kind of in the same group. If not, you got to represent the group so that you can do your HCF. So let's recall, how do you get the HCF? You will get the HCF by taking the highest power in each of the family. So go ahead and, sorry. HCF is, you are going to get it by the lowest, yeah, I say wrongly. So it's the lowest power in the family. So upon doing this, you will get a 24. So the HCF between the 48 apples, 72 oranges, and 96 pears will be 24. So what is the significance of 24? That means, right, you can actually prepare 24 fruit baskets. So the significance of the HCF is it relates to you the 24 fruit basket that can be prepared. So sometimes the question can be further asked for you to continue. So they will be asking, even if they don't ask, right, you should also be thinking this way. So now that this is the maximum fruit basket. So if you're going to ask them in what kind of fruits are in each fruit basket, so you may want to think about this. So if I'm going to divide the 48 apples into the 24 basket, each basket is going to get 2 apples. And then 72, I'm going to divide into the 24 basket, and I'm going to get 3 oranges. And then for 96, I'm going to divide by 24. I actually get 4 pears. So if the question indicate further, or you are supposed to find. Sometimes they will ask for it. So what are the number of fruits? They can ask for the total number of fruits. They can ask for the variety of fruits. So anyway, in each, your thinking should be right. There are 2 apples, 3 oranges, and 4 pears in each basket. So that's how we use HCF. So we apply HCF when we're trying to divide the numbers. So the next question, we got 2 schools. They are situated next to each other. So there is a school A and then there's a school B. So you will hear a bell to start lesson. So the first lesson, the 2 of schools is starting at 7:40. Okay, for the first school, every 30 minutes, the duration of a period is 24 minutes. So after 24 minutes, then there will be a bell ring. For the second school, after every 30 minutes, there's a bell ring. So at 7:40, right, there's a ring. So both schools is going to start lesson. Okay, so then in this question, right, every 24 minutes, let's talk about the first school first. For the first school, after every 24 minutes, then they will ring a bell. So 24 minutes, they will ring a bell. 48, it will ring a bell. 72. That means is that you are exploring the multiple of 24. So every multiple of 24 for the first school, right, it will ring a bell. For the second school, every multiple of 30 minutes, it will ring a bell. So 30, 60, 90, 120. Then you realize that there is a common number here. So when there is a common number, that means they are going to ring together at the same time. So in this case, right, what are you exploring? You are exploring the LCM. So you're exploring the LCM. Okay, so this is your thinking. So do not show this as you're working. But if you have this thinking, it will lead you to apply your LCM. So after you realize that you are going to do a LCM, go for the ladder method, get the answer, and make sure you can group them into each family. For the LCM, you're going to take the higher power. So you're taking the higher power. So you get 120. So what is the units for this 120? So you should ask yourself, what's the unit for this 24? So this 24 is in minutes. 30 is also in minutes. So the LCM you've gotten is also in minutes. And what is the significance of this 120? That means, right, every 120 minutes, the 2 schools will actually ring bell together. It will ring their bell together. So then you got to answer the question. The question is asking you what time after the start. So the school starts at 7:40. So what time after the school starts and the next time, what is the next time where the 2 schools will ring their bell together? So you got to do the conversion. 2 minutes is equivalent to 2 hours. So 2 hours after 7:40. So at 9:40, the 2 schools will ring the bell together. Okay, so this can be one of the questions they ask. Sometimes they will ask a little bit more. They will ask, right, like for example, the school is going to start 7:40, and if the school is going to end like 1:40, So the school ends 1:40. So how many times do they actually ring together? So sometimes they will ask you for the number of times they ring together. So this one, they ring once. And 9:40, they're going to ring once again together, the two schools. And then 11:40 is they are going to ring together one more time. So here they will ring together again. So they from here, right, you will hear four timing. There will be four timing where the two schools actually ring their bell together. Sometimes they ask for the number of times. So you might need to be a bit more careful about what they ask. Okay. And sometimes they can even ask, so if they end school at 1:40, so how many periods are there in school A? Lesson period. And in school B, how many lessons period are there? They might also be asking this kind of simple thing. Okay. So hopefully by these two examples, you got a little bit of idea about HTF and LCM. Okay, let's talk about the next two examples. So in the next two example, we got battery operated toy train. So they're going to like go around a circular track. So for the first train, okay, every 18 seconds, they will complete a round. So for the first train, 18 seconds, it will complete a round. So for the first train, 18 seconds, it will complete a round. That means 36 seconds, it will complete 2 rounds. And then 36 seconds, it will be 3 rounds. So we are listing the multiples of 18. So these are the timing that it will complete 1 round for the first train. For the second train is 24. So every 24 seconds, it will complete 1 round. 48 seconds, it will complete 2 rounds. 72 will be third round. 96 seconds, fourth round. 120, fifth round. So we're going to explore. So for the third train, it will take 36 seconds. So 36 seconds, first round completed. 72 seconds, second round completed. So you're listing the multiples of 36. Okay, if you explore carefully, you will get a common number here. So this is the time where they meet at the starting point. So this is the time where they meet at the starting point. So meet together after they start from the same starting point. And then the next time they will meet at the starting point is actually 72 seconds. So this is a LCM question. So again, if you know that you're going to do the LCM question, okay, apply your prime factorization first. So do your ladder. Okay, so I'm not showing the ladder, I'm just showing the prime factorization. And get your LCM. Get your LCM from the higher power. So in this case, you will get the 72. So again, what's the units of 72? All these are in seconds. So the LCM you got will be in seconds as well. So the significance will be every 72 seconds, the 3 trains will meet at the starting point. Everything disappeared. Okay. So I will start from this part. So do your LCM, get the highest power, and that will be a 72. So if everything here is in seconds, the LCM you gotten will be in seconds. So the significance will be something like every 72 seconds, the 3 trains will meet at the starting point. So there must be a significance where you do a HCF and LCM. The significance must apply to the context. So in this context, we're talking about 3 trains. So just now the LCM context was about the timing of the bell ring. So the last one, okay, this lady had 3 pieces of rope. So 120 centimeter rope, got 180 centimeter rope, and then 240 centimeter rope. So she's trying to cut the rope. So when she's trying to cut the rope, essentially she's going to divide the rope into, you're going to divide the rope. So we're going to divide the rope. So in this kind of context, we are exploring the factor. So we should be exploring the factor. So it will be a HCF question. So if you know that it's a HCF question, okay, do your prime factorization first. So do your prime factorization, make sure you arrange them in such a way that you can compare to get the HCF. So the HCF is the highest, sorry, the HCF is the lower power. So that is 60. So everything here is in centimeter. So your HCF is also in centimeter. So that means, right, the significance is you can cut them into 60 centimeter pieces. So the small piece of rope that she's going to cut is 60 centimeter. So that is for part A. So eventually after cutting, right, how many small pieces of 60 will she be getting? So if this is 120, she will get 2 pieces. From the shortest piece, she will get 2 pieces. 2 pieces of 60. And here, it will be 3 pieces. From the 180 centimeter piece, you will get 3 pieces. From the longest piece, you will get 4 pieces. So the total pieces, after she decides that she's going to cut, will be 2 plus 3 plus 4. So we will have a total of 9 pieces. So you need to be able to tell whether a story sum is HCF basis or LCM. So once you decide, you execute the same method, prime factorization and HCF or LCM. But then you need to know a significance according to the context of your HCF and LCM. So sometimes the question can be a bit tricky. You have to use a bit more common sense sometimes. But you cannot run away from the basic of HCF and LCM.